will learn a new concept called loop gain. This is confusing, but you need to really memorize it or put your cheat sheet. Make it very clearly, just three statement, make it clearly. What are the definition? We have learned something called open loop gain, right? Open loop gain is A1, right? So in this case, this is just A1. Open loop gain is that you did not hook it up to any circuit, right? Now, what is the closed loop gain? Or maybe I should, maybe it is better to say this, right? I call this X, this Y, this Z. Open loop gain, of course, A1 equals to, what is that for this free variable? No, A1, X, Y, Z. Z.
Assuming k equals 0, then it's the x thing.
No, not assuming k equals 0. But I gave you the variable already, right? Just pick from the variables that I gave you. What is A1?
Y.
Is it just Y? The gain, right? A1, what is A1? Y over Z. And maybe you thought that I'm asking other things, too trivial. That is the gain, right? Okay, then how about the closed loop gain? By definition, Y over X. Now you know what I'm asking. Right. So if you go for interview, sometimes they ask you some question looks stupid, or actually they did not ask you in the right way. Do not get nervous, right? And completely surrender, right? Just keep saying, just keep talking out what you're thinking. For example, just now, instead, you did tell me what you're thinking, right? You say, oh, this A1, assume K is 0. Then people know that actually they are just asking the question in the wrong way. But if you just say, or just stand there and be silent, or just give the final answer, they will feel that how come even you don't know the most basic thing? They will not realize that they're asking something that is wrong, right? And I realize that sometimes in my exam, because of my English, I will say, what is GM? Some people tell me, oh, GM is transconductance. What I'm asking is ask them to calculate GM, right? So I start realizing it's my English problem, right? It's not that they don't know how to calculate.
We'll make sure to write that response whenever you say what is GM the test.
Yeah, anyway, so remember, always keep thinking loud. Thinking loud is important in interview and meeting. Otherwise, people will think that you don't know anything, right? Okay, so this is the so-called loop gain and open loop gain and closed loop gain. So what is loop gain? Loop gain is that you have a few steps. The first step, you grant the input to find the loop gain of a circuit or a feedback circuit, right? You grant the input. Okay, so that's why you see that this is grounded. Okay, and then you cut the feedback loop, cut it. Okay, at any place that is okay, cut the loop. Because the result will be the same. I just cut it. Okay, and then how do you find the loop gain? You add the test circuits to one of the ports and measure the output in the other end. That's it, right? So here the loop gain, it even doesn't have a symbol, is equal to Vn divided by Vtest. So basically you see that it's telling you that if I don't have input, this basically is telling me how much amplification I have when I go around this loop. But the only thing you need to be careful is that you need to go in the right direction. Of course, you can say, I want to go in the loop in this direction, but this is not the original intention of this feedback, because we're trying to get something from output and feedback to the input. If you go in this direction, you actually try like this, then you actually try to, this will be the feed forward and this will be the feedback, right? It's possible there's still some feedback, but it's going to be very tiny, it becomes meaningless. Because when you design the circuit, you already have an idea where is the feed forward direction, and then you add the feedback. So when after you cut it, you need to walk in the direction along this loop. Is that okay? Because you already have the intention, say that input is on the left and the output is on the right of A1, right? Instead of going in the other direction. Is that clear or not? Do I explain clearly? Yeah.
Why would it not be the case to be able to just position after K formation that there?
You can. Or you say I just cut here and then just look at V in, how V in go through, right? That will be the same, right? Think about this. If I cut here, then it won't be the same because of the sign. Now, so let's go back, step back. So what he's saying is very good, very good for discussion. I told you I can cut here or cut here, right? It doesn't matter, or even can cut here. That is okay. So he said that let me just cut here, and then my definition is just apply the test voltage to here, and then you go for a loop. Now, if you ignore the sign, it will be the same because in my definition, you are going to apply a voltage here, right? Test voltage here, right? And then you go over the loop, right? Let's draw it. So I mean, it's a good discussion. Let's draw it like this. Let's try to go through this. So what he's saying, before doing what he is saying, let me do what my definition. I'm going to apply the V test and then measure Vn here. Is that okay? This is my definition, right? I cut it here and then apply a V test here and then go through the loop and then get this, right? So, right. So now you see clearly because if I apply the test instead of here, I put here. This is plus, this is minus. So what I get is a negative loop gain. So it's different from the definition. But if you won't have to have a negative definition, that is fine. It's all up to you. But you need to be consistent and let people know that that's what you're doing. Okay? But in this class, we need to use the definition I gave you.
But the negative loop gain is the common form of the loop. Any feedback circuit, because they're usually stable. It's uncommon to be the positive loop. Feedback loop, because those, I mean, there's applications for it, but it's unstable.
Right. But the point is how they definitely need to have a negative loop gain. But the number, how you define the loop gain, it depends on you. For example, if it is positive, you can call it a negative loop gain, right? Depends on how you define it. But overall, yes, the concept is you need to have a negative loop gain to get the stable system. Okay, and that is kind of related to this. I'm using a definition that is different from the textbook. Okay, so it is opposite of mine. Now you have two choices. One is just ignore the textbook, only use mine. Always just use mine, which is opposite to theirs. And if you really like the definition of the textbook, you use the textbook one, but you need to be consistent because this is not going to change the result. Because if you use theirs, the result will be the same as mine, as long as you are consistent. Okay, but I'm still using this definition. But look at this one. Can you tell me why this is called the loop gain, right? Yeah, I put the Vn here, V test here, and then go through this, right? What is it equal to actually? We can just go through it, right? Yeah. What is the gain around the loop? Yes. What is this point in terms of V test? What is the point after K? Yeah, very good. K times V test, right? But this is not Vn yet. What is this point in terms of V test? Negative K V test, right? And what is this point? Yeah, just multiply one more A1, right? So divided by V test. And this is just negative KA1, right? And that's why I say it is different from my definition here. They actually call it KA1 as the loop gain. Okay, so you just make sure that you know, make sure what definition people are using. In my case, I'm using negative KA1 as the definition. Then why do we want to know this? Because from there, we will know that whether it's negative or positive feedback. But now I gave you the definition. I still want to introduce a few two ways, how to find out whether it's a positive or negative feedback, right? So in this case, I forgot to say this. In my case, if it is less than 0, this is a negative feedback. Okay, when it is larger than 0, then it is a positive feedback. Okay, so if you want to see whether it's a negative or positive feedback, one way is to look at the loop gain. Okay.
If we have the system diagram, we can just do it by inspection.
Yeah. So the first thing, for example, on the left, there is another way to find whether it's a positive or negative feedback. And it is very easy. How I do this is just start with your signal. For example, I say, let me increase the signal here. Okay, what will happen to the signal here when this is increased? Is it going to increase or decrease at this point? You say increase, why? Because we're adding. Yeah, I increase my input. This one is going to increase, right? Do you agree? Anyone? Okay, then what happened to this point? Increase? Yeah, because it's just an amplifier. Now you might say that, what if A1 is negative, right? Let's just assume they are positive. Okay, in this case, yeah. Then what happened to this point? Also increase, right? Too simple, right? But be brave. Yeah, you're right.
But it goes to minus, so it decreases.
Then eventually you come to here, right? What happened? It's going to decrease because it's negative, right? Because we're doing a negative feedback, right? So 2 contradicts 5. Contradict doesn't mean that it won't happen. It's just that they're going in a different direction. Then it means this must be a negative feedback. Right? Yeah.
To take a page out of 132, since we have V in and V out, we can identify forward and then closed loop from the forward. So like we can see that it loops out. You're missing actually V out in your diagram.
Yeah.
Which is,
This is we out,
No.
yes.
it's not annotated. But if we can see that if we can identify the section that has the loop, we can just look to see what the input signs are on the summer.
Yeah, you can
From
do
there you can determine it.
you can do that, but the reason I do this is when we come to a circuit or the transistor, it won't be that simple, right? Here it's just to tell you the methodology, right? If you have a 100 transistor, then you need to trace through this transistor. You even don't know whether it is plus or minus. Yeah, so this one is just like, this can be negative or positive. It's just that when I demonstrate, I assume they're positive, right? Then you go through this, like what I've done. So the point is that you need to find out whether it contradicts or not. The second method is just like what I told you earlier, right? You cut the loop and just do the calculation. This is to find the loop gain. This is to find the loop gain. Here I did not find the loop gain. I only just trace through and see whether they go in the same direction or not. Then I know whether it's positive or negative, right? But here I find the loop gain. Like last page. Yeah, again, I use a different definition as from the textbook. Is that okay? Any questions? Now, so we have all the